Alright, so, as promised, figured I would go through and work through the practice quiz 1A. So for this one, we're on the Canvas quiz for it. We've got ourselves our little engineering drawing. Generally, it is recommended that when you are working on one of these sorts of drawing problems, you've got some way to mark on the drawing which dimensions you've already used and which ones you haven't yet. Helps make life a little bit easier. Um, and as far as the actual quiz itself goes, when y'all are taking it, it's going to be handed out on a paper sheet, so you'll be able to just do crossings there. However, so that everything remains on the screen, I'm just going to use the snip tool so that we've got our little doodle space as well. Oop, that is a bit much. There we go. Yeah, there we go. Awesome. We'll probably use the highlighters, you can still read it. But anyway, when you first get set up in the classroom for the quiz, I recommend you get SOLIDWORKS open, get a new file open, and then we have our units set. So on the front of the quiz handout, there's going to be a little thing specifying the units. It's either going to be inches or millimeters, and we can set that with the little drop-up menu down at the bottom right. This one is in millimeters, so mm. Cool. Alright, so got our file, got our drawing. Let's see. Usually, a good place to start is to consider sort of what feature we might want to do first. So this would be anything that's got kind of a majority of the geometry going on is generally a good spot. See in the top view, that's where we've got a lot of our dimensions, and they sort of describe the profile of this sort of base feature that we have here. So we've got some outer extrude that's taking up the majority of our space, and then we've got sort of an offset inner extrude and an extrude cut for this little circular hole here on the right side. So we're probably going to want to create this starting on the top plane. We'll draw the outer outline of it first, create our extrude. Then we can do an offset entities to get this inner loop, similar to how we would recommend, or similar to the easier method for approaching a similar shape on the first homework assignment. And then we are going to do the extrude cut last, because we see this hole goes through both of these sorts of stacks of material. So, beginning by creating ourselves a new sketch. This one's going to be on the top plane to make sure that our orientation matches. And as far as origin locations, there isn't really any specific point that would benefit from having the origin there. So we'll just have it in the bottom left. Makes sense. And start by drawing in our outline. So we've got a vertical straight line. Then we've got a little diagonal going down to the right. Then another vertical over here. Horizontal to go over. Then we've got this sort of tangent arc, so it connects in smoothly on that side. So we can do the auto transition feature by bringing the cursor back to where we started that line, and then tracing out a little bit of a circle, and then clicking down here. And then we see we've got another arc, so it connects in smoothly from there to there, and we do see that we've got these gray tangent edges in our isometric, indicating that those do in fact have a nice smooth connection between the geometries. And then we've got our final arc here. Little vertical line segment down there. Another diagonal. Looks like that brings us close to the beginning, but not quite. And then a horizontal to close it off. So we've got now a fully closed shape. So all's good so far. And then we just need to throw some numbers at it. So looking this one over, we see that we've got 67 units on the left side, so we'll dimension this one there. Then we've got cross that out. I guess also because it's going to bug me if I don't. We can change this from the ISO drafting standard to the ANSI drafting standard. So this is through the little options gear up in the top. Under document properties, for whatever reason, the default ANSI in SOLIDWORKS 2025 is set to the ISO perspective for this. So if we change it to ISO and then change it back to ANSI, that fixes it. I don't know why, but we're just going to go with it. Anyway, we've got our 42 dimension up here, but this one's in parentheses, so that tells us that this dimension is a reference dimension, so we can't use it directly. We're just going to have to hope that as we hit the rest of our dimensions, everything kind of comes together. So, from there, got this 75-degree angle. So we can measure an angle just by selecting two non-parallel lines. And it'll allow us to get the angle between them. Then we've got 45 units from the top corner of our object down to the center of our arc. So that's going to be from that point to that point. And we want to make sure that we're being very careful that we're measuring the height here, not the distance. So it's explicitly from there vertical. 45. Cross that one off. Then we've got a 2x R9.5 indicating these two arcs. So with those, we know one of them needs to be dimensioned, so we'll dimension this top one first, 9.5, and then the 2x tells us that there's another arc that uses that same dimension. So that's probably going to be this one that is connected with over here, since that's the only other sort of arc in the area. Another potential thought could be that it would be this one on the inner loop, but that isn't really something that we would be able to use here. So it's going to need to be this outer one. And to get it so that this one dimension is affecting both of these arcs, we're going to need to use the equals relation. So we can select the one, hold down shift, select the other, and equals. You might need to hit escape a few times when you're first doing that, depending on if you had any other tools selected, but that does get that set up for us. 2x 9.5. Another thing that we can notice while we're here is that the center marks for these two arcs are vertically aligned with each other in the drawing. So we've got one of the extension lines actually connects between the two. So I'll just grab those 2 points in the middle, apply a vertical, and that sort of sets those up to match up nicely. Another thing that we can notice regarding our geometric relations is that we have a little guideline showing us that this top vertical edge stays lined up with the bottom vertical edge. So these two lines are going to need to be collinear with each other. Same song and dance as before, hold down shift, select the both, and we can apply a collinear relation. Cool. Then we've got our 47.5, specifying the distance from this little shoulder to the center mark there. So smart dimension from that point to that point, 47.5, there we go. And then the last dimension that we've got for this outer loop is this 4. So with our smart dimension tool, define that distance as 4 units. And that looks like that's got it. We are still a little underdefined, but we do have another reference dimension that can help us out here. So this one's telling us that this diagonal down here is also at a 75-degree angle. But since it's in parentheses, we can't use it directly. But we have another 75 up here. So if we just set a parallel relation between our two diagonals. Okay, I can't be sneaky about that. There we go. If we select both of our lines, apply a parallel relation, that then gets our sketch fully defined. So then we can do an extrude up 30 units. So we'll pop out of features, extrude boss base. This one is 30 units. Check mark. Cool. So that gives us our first feature down. Then we've got this little offset or inset bit where we see this one goes 40 units from the bottom of our object up to the top. So for that, what we could do is we could do the sketch here on this top surface, extrude up to some offset of 40 units from the bottom, or make our lives a little bit easier with the feature, we can actually do the sketch on the bottom face of our object and extrude through all of the existing material. So we'll select that bottom surface, new sketch, do an offset entities. This one, our offset is 2 units, indicated by the 2 TYP up here. And then we can reverse it to set it so that it is offset inwards. Check mark. From there, features, extrude boss base, This one extrudes up 40 units. Flip our direction as needed, and that looks good. Control 7, you want to do this usually after every feature or two to make sure that your orientation matches the orientation of the object that you're trying to model. So it's pretty much important for making sure that when we create our drawings, the orientation that we're working with ends up being consistent with a usable isometric and good front, top, and right views. Alrighty, so that was the 40. Our last two dimensions that we've got are diameter 10 for that hole, and it goes to a 20 unit offset from the shoulder. So we'll create a new sketch on this top face. Circle. This one we've got centered in the same place as the previous one. We've only got the one center mark there and 3 arcs. So that tells us that all 3 of these need to share that same center point. So if we hover close to where the middle of it should be, then it'll pop up. Otherwise, if we just draw the circle out in the void, we can then grab the edge, hold down Shift, grab the other edge, and apply a concentric relation manually to sort of snap these to be nested within each other. Then we can use our Smart Dimension tool to define this as having a diameter of 10 units. And then Features, Extrude Cut. This one, we want it so that it goes down 20 units from this shelf. So we can do offset from surface, that face, 20. Cool. So, another way that we could approach that one is if we did that sketch on the shelf, then we can do down 20 units as the blind end condition, and then we can choose direction 2 and set that to through all, so it goes up. So effectively, we can create a new sketch on the shoulder. Let's hide that previous one. Create our circle, center edge, circle, concentric. This one is 10 unit diameter. Then extrude cut. It goes down, so blind, 20 units. And then we can set a direction 2 to go through all, so then it'll cut everything above it. So, slightly different way to approach the same thing. There's usually an arbitrarily high number of methods that are equally valid. Some of them a bit more elegant or a bit faster than others, but as long as we're following best practices, they're all equivalent. So, that wraps up, or I guess Control 7. Yep, looks like what we're going for. That wraps up this little recording. Hopefully that was useful. Feel free to reach out if you've got any questions. Otherwise, best of luck on studying. Hope it goes well. Bye.